Okay, so we're going to look at some applications of quadratic equations. And here you have a problem that is involving making a trough at the end of a gutter spout, is meant to direct, and not director, water away from the house. The homeowner makes the trough from a rectangular piece of aluminum, so it's a rectangle that is 20 inches long and 12 inches wide. He makes a fold along the two long sides, a distance of X inches away from the edge. If he wants the trough to hold 360 cubic inches of water, how far from the edge should he make the fold? So what's going on here is that he's going to fold up the edges of the trough, each side the exact same amount, and that will be X. We don't know what that is, but we do know that we want this trough to hold 360 cubic inches of water. And of course, it can't hold it for very long, but because the ends, it will just come out. But that's the whole point. It's supposed to be like a gutter, right? So we just want it to represent a box that has a width and a height, a certain width and height and depth, so that it will hold 360 cubic inches of water. So this is what it's going to look like after you fold those sides up X amount on each side. The width used to be 12, but now that you've folded up each side X, it's 12 minus 2X because you subtracted an X on this side and an X on this side, and now those parts are sticking straight up, and it makes the trough X inches deep now, 12 minus 2X inches wide, and 20 inches long still. So the volume that this will hold is going to be length times width times height. So you've got 12 minus 2x times x times 20. And that is the volume that this gutter will hold. And you want that to be 360 cubic inches. So if we multiply all this out, we are going to have 20. Well, first of all, we'll have 20x times 12 minus 2x if we kind of rearrange the left. And then if we use the distributive property, we're going to have 240x minus 40x squared equals 360. So this is a quadratic equation. We want to get it all in order, and we want to get everything on one side and have 0 on the other side. So if we do that, we're going to have negative 40x squared plus 240x minus 360 equals 0. Now, in order to deal with this, I would rather not have such big numbers in front of all my, my coefficients. I don't want them to be so big. So I can just divide this whole equation through by negative 40 to kind of get rid of some of that mess. Because this is an equation and you are allowed to divide both sides of an equation by any non-zero number. So I'm just going to go through and divide everything by negative 40. And that'll make it look a lot better. So it'll be x squared minus 6x plus 9 equals 0. And this is so easy to factor that I wouldn't bother using the quadratic formula because it's just x minus 3 times x minus 3. And so that is going to mean that x has to be 3, because if you multiply two things together to get 0, one of them has to be 0, and the only way for these factors, either one of them, to be 0 is to put in 3 for x. So x minus 3 is 0, means x has to be 3. So the amount you fold up the edges is going to be 3 inches, and so that's the answer to the question, how far from the edges should he make the fold? That's going to be 3 inches. Okay, a window is in the shape of a rectangle with an adjacent right triangle above. The length of one leg of the right triangle is 2 feet less than the length of the hypotenuse. The length of the other leg is 1 foot less than the length of the hypotenuse. Find the lengths of the sides. So it's kind of a weird problem because they're not really asking us anything about the rectangle. They just want to know what the sides of the triangle are, which is fine. But it just seems kind of weird that they'd have that rectangle there and we never find out what it is. So that's okay. We know that for a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So x squared is going to equal this leg squared plus this leg squared. And when I multiply all this out, I'm going to have x squared is equal to x squared minus 2x plus 1 plus x squared minus 4x plus 4. And if I move everything to one side, get 0 on the other side. And so this also is easily factorable. I would not use the quadratic formula unless you had to. So if you factor this, you can factor that into x minus 5, x minus 1, and that's supposed to equal 0. So that means that one of these things has to be 0. So either x minus 5 is 0 or x minus 1 is 0. And so x would be 5 and x could be 1. So if x is 1, that's impossible because that will make the legs negative. So it can't be 1. So x would have to be 5. And if x is 5, that means that this side is 5, this side is 3, and this side is 4. And that's a right triangle. That's perfectly fine. And it works for everything. So the length of the other legs, that find the lengths of the sides. So the lengths of the sides are 3, 4, and 5. All right, here is what we call a vertical motion problem. If an object has an initial vertical position of s sub 0, so that's where it starts, and an initial velocity of v sub 0, straight upward or downward, then the vertical position s of the object is given by s equals negative 1/2 gt squared plus v sub 0 t plus s sub 0, where g is the acceleration due to gravity, and on Earth that acceleration is 32 feet per second squared, or 9.8 meters per second squared, depending on whether you do meters or feet. And then the time of travel is t. V sub 0 is the initial velocity. S sub 0 is the initial vertical position, so how high you drop it from, or how high you shoot it up from, or wherever. And then S is going to be your vertical position of the object at a time t. So suppose a child tosses a ball straight upward from a height of 1.5 feet with an initial velocity of 48 feet per second. These are the values that you would have from that problem. So the initial height, it says, is the child is shooting or throwing the ball straight upward from a height of 1.5 feet. So S sub 0 is where you start. So 1.5 feet. V sub 0 is your initial velocity, which they tell us is 48 feet per second. The acceleration due to gravity is up here. It can either be in feet per square second or 9.8 or meters per second squared. So it's going to be 32. In this case, we're talking about feet. So we would put 32 feet per second squared. And then the vertical position of the ball in feet is given by this function. S equals negative 1/2 g times t squared plus v sub 0, which we just said is 48, t plus s sub 0, which is 1.5. So this would be the equation that represents the height of this ball after t seconds in the air. All right, so there's the formula for vertical motion. A toy rocket is shot straight upward from a launch pad 1 meter above the ground. So that right there is where you start from, s sub 0. With an initial velocity of 24 meters per second. So that's your v sub 0. And so A, you're going to write a model to express the height of the rocket S in meters above the ground at time t. So that is going to be S equals negative 1/2 times the acceleration due to gravity, which, since we're using meters this time, is going to be 9.8 meters per second squared. So 9.8 will go here. And then t squared. We don't know what the time, it could be, the time is the variable. Plus v sub 0, which is 24, t, plus s sub 0, which is 1. So that's the model. And then part B, find the time at which the rocket is a height of 20 meters round to one decimal place. So I'm trying to find out t, what value of t will make the height of this rocket 20 meters. When is the rocket 20 meters from the ground? So looking for that time. So S is 20. When does that happen? So that's going to be negative 4.9 t squared plus 24t plus 1. Now I have a quadratic equation. I want to get everything on one side, so I'm going to subtract 20 on both sides, and I'm going to have negative 4.9 t squared plus 24t minus 19 equals 0. So I have this equation. I need to solve for t to find out when this happens. When is this toy rocket 20 feet above the ground? That's what I'm finding out. What time? How many seconds will have passed? All right. So this obviously I want to use the quadratic formula for this because it's just a mess. So one solution for t is going to be 3.90 seconds. The other solution is going to be 0.99, which they ask you to round it to one decimal place. So really, we should round that to 1.0 seconds. So there are two times at which this rocket is 20 feet above the ground, once on its way up and once on its way down. So the rocket's going to go up and come back down. So at some place there, it's going to be 20 feet above the ground once and then again. So after 1 second, it will be 20 feet above the ground. And after 3.9 seconds, it will be 20 feet above the ground. So there's two places where two times where this rocket will be at 20 feet above the ground. All right, find the time at which the rocket is at a height of 40 meters. We would do the exact same thing, except now instead of a 20 right here, we would have a 40. So I'm going to have to erase this little beautiful drawing I did right there. So I'm going to put a 40. 40 equals negative 4.9 squared, t squared plus 24t plus 1. And then I'll subtract 40 on both sides. So I'll have 0 is equal to negative 4.9t squared plus 24t minus 39. And I will use the quadratic formula again and punch that all in. And so I will have negative b plus or minus the square root of b squared minus 4ac all over 2a. And if I do that under the radical, I'm going to end up with a negative number. Gives me negative 188.4. So I end up with a complex value for t. And so this rocket never hits 40 feet. It doesn't happen. So never, no time, at no time does this rocket reach 40 feet. So that's what that is.